So welcome to the industrial classroom, and in this class we will learn about the process of length calculation of conveyor belts. Okay, so here we can see these are the two conveyor belts here in this image. So the first one which we see here, it is a type of, we can say it is a spherical roll or a radial roll. Okay, and here we have two centers in this case, and it will something look like this, and this will be, this is the belt, and here one center, here one center. It is the elliptical roll. Okay, so we will go with the easiest method, the fastest method, with all the understanding. Remember, for spherical roll the formula is very easy, but in case of elliptical roll you need to understand a bit. Okay, so this is the elliptical roll. Here we need three types of dimensions, three dimensions rather. So d is the outer diameter. Okay, outer dia, this you can see it is represented here. Small d, it is the inner diameter of the coil, and n is the number of turns. If you zoom into this image, you can see that there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There are n number of turns. So the number of complete turns. Okay. So for example, here the number of complete turns you have to take. So here you can say 1, 2, 3, 4, 5. These are the number of complete turns. Okay. So n is the number of complete turns. So the formula is the length of the elliptical roll is equal to OD plus ID. Remember, OD plus ID divided by 2. Okay, into number of turns into pi. Or you can simply place here OD plus ID divided by 2 into n into 3.14. Here all the dimensions must be in mm. Okay, number of turns is number, so it is not in mm here, and the length will be in mm. Okay, let us take an example to better understand. If my OD, here you consider my OD as 1000, or let me consider it as a bigger roll, 2000, and my ID is equal to 1000, right? OD ID, and my number of turns is equal to, consider it as 100 turns. Let me consider it as a very bigger roll, right? Now we have to take out the length. What will be the length in this case? 2000 plus 1000 divided by 2 into number of turns is equal to 100 into pi, or 3.14. We receive here 2000 plus 1000, that is 3000 by 2, that is 1500. 1500 into 100 into 3.14. The value will give you the dimension in mm. Okay, to take it in meter you have to divide by 1000, so it will give it in meter, right? So this is the formula. Also remember, before understanding the elliptical roll, let me consider you another formula of this, because we will now go to understand the elliptical roll. We learned that d plus d by 2 into n into 3.14. Okay, what happens if I am unable to take the larger diameter? For suppose I am only able to take the smaller dimensions, that is without the, I am taking r here, and this is my small r, right? So if I have very bigger roll and I am only able to take the r, we can write that larger dimension, remember this is capital D and this is small d. So we know that d is equal to r into 2. Okay, larger radius into 2, or we can say r is equal to d by 2. And here we will also see d is equal to r into 2, or r is equal to d by 2. Putting this in formula, d, which you can write it as 2r plus 2d divided by 2 into n into 3.14, or we can write 2 will cancel out, we can write r plus, sorry, it is 2r, r plus r into n into pi, or 3.14. Remember this thing, because whenever we will come to the elliptical roll, see, for spherical roll you don't need to remember anything. This is the only formula that you have. Okay, capital D, outside diameter plus inside diameter divided by 2 into number of turns into pi. For outside diameter, I was explaining you this thing of the elliptical roll. For elliptical roll, remember we have two centers here. See, this is one center, this is one center. Let the center to center distance be C. Right? Now here we have a larger diameter, that larger radius R, and we have an inside radius small r. Right? Same in this case, it will be capital R, this will be small r, and we also have number of turns. If we divide it into two sections, here we can say that if I split it from here, then this part along with this part, okay, this part along with this part, it will form a circle. I will merge it together and it now forms a circle. Okay, and this part is the extra one. See, this is the extra part. Okay, now here this is the metallic one, and here we have the number of turns. So here we need to add the sum of the length of the roll in the circle plus length of roll here. Let us go first to the next page. Let us draw this diagram another once again to better understand. Center, center. Okay, so here this is the portion of my belt. Done. Now I am ready here with center to center. See, this is my center to center. See, this is my capital R, and this one here we can say, or here the small one we can say, it is the small r. Right. So now for the circular roll, we have studied that since this part number 3, this is part number 2, this is part number 1, here we are splitting the parts. So part 1 plus 3, it will make a circular roll. So for circular roll we have r plus r, not divide, because if we have d, then we will divide it r plus r into number of turns into 3.14. Done. Now we will add it with other value. Which one? The value of the length. So here the distance is c. C into number of coils. You can directly count from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It will be okay. Or else, if you don't want to count twice, then what you will do? You will count from any other one side. The number of turns, let it be 10. So in this side, we also assume it is 10. So here it will be 10 into 2. Okay. But in some cases, you might find that the belt roll comes and it ends here. So here you will not count this turn. Remember, you will not count this turn. You will take 10 plus here a roll will be less. So here it will be 9. So you can count it as C into 19 rather than 10 plus 9, rather than C into 20. Dividing, multiplying it. So now the total formula becomes R plus R into N into 3.14 plus center to center distance into 2N if you have full rolls, or in case of incomplete roll, you will write R plus R into N into 3.14 plus C into, without 2N, here you will write the Tn, or the total number of turns, 1, 2, 3, 4, 5, 6, 7. For example, let me take you an example here. This one is over. Let me just see. This will help you in understanding this. You will never forget the concept behind it. Therefore, the video will be a little bit long, but to understand the concept, you need to remember it. See, I am taking an example here. Let me make this hole a little bigger. So this is my belt roll, right? Now here we have 1, 2, 3, 4 turns. 1, 2, 3, 4 turns. Right, 4 turns here, or another turn here, and a 5 number of fifth turn here. See, this is the fifth turn. Now let me consider the R. R is equal to 500 or 1500. Let me take it 1000. R is equal to 1000, and small r is equal to 500. Okay, so here my formula becomes capital R plus small r, that is 1000 plus 500, that is 1500, into number of turns. See, the complete number of the total number of complete turns. So here we have 1, 2, 3, 4. Here we have the roll starts from here. Okay, so here also we have 4, but in this case we will have 5. 1, 2, 3, 4 and 5. Okay, the roll starts from here, goes in this direction, comes here, goes in this direction. See my movement of the pen here. You can track the roll. Okay, you can see how this is tracking, right? So here you can say that the number of turns here is equal to, complete turn is equal to 4, but we have one extra one, so we will not count it. 3.14 plus here you have, see, that is that the distance between this is 2 meter or 2000 mm. So 2000 into center to center distance, we have taken 2000 into number of turns. See, here we have 1, 2, 3, 4. Here we have 1, 2, 3, 4, 5. In case there had been 4, 4, then we have done 2 into 4, that is 8. But since they are different, so 5 plus 4 is equal to 9. So this is the total length of this elliptical belt in mm. To take it on meter, divided by 1000, and you will get it in meter. So this is the complete formula. Remember it. Till then, take care and support us.